Welcome back, everyone. My name is Vandana Saxena-Poria, and I'm your guide of ceremonies today. So hopefully what you've seen from today so far is there are countless opportunities and, of course, risks also associated with Industry 4.0. Now let's move to Dhirendra Kulkarni, who's the Senior Director of Pre-Sales at PTC India. PTC is the leading provider of power trading solutions in India and provides credit risk mitigation to private power project developers. Dhirendra is going to look at how our companies in India can unlock the value and capitalize on the promise of Industry 4.0, from looking at augmented reality to industrial IoT, and show how companies such as Bharat Forge and others are already embracing this. Dhirendra, over to you.
Hello, good evening, everyone. My name is Dhirendra Kulkarni. I'm a Senior Technical Director at PTC. I have an overall around 25 plus years of experience and last 16 years in PTC. So let's start the presentation. Let me share my screen. So in my today's session, we will see how Industry 4.0 has really revolutionized the way the manufacturing is done, and we'll see what is Industry 4.0 is all about, what is the value that it provides, how organizations have realized this value, and what are the most widely used or the high impact use cases, and of course with a word of caution as well. So let's start. So before we start, let's a little bit understand the pre-Industry 4.0 and the post-Industry 4.0 scenario. In the pre-scenario here, we have two words, right? Digital word and a physical word. And we use the technologies such as CAD and PLM and ERP to really design, manufacture, and release the product to the market. For example, you see this as a pump which is there in the field in oil and gas industry to circulate the water or liquid. There can be a CNC machine in the factory for doing the manufacturing operations. But these products or these equipments are not connected, right? So there is no way that to get the data on how these products are performing under different climatic conditions back to the OEM or digital world. There is no technology really that enables to do this. So how does Industry 4.0 really changes this or transform this? So let us see what is the definition of the Industry 4.0. It's basically real-time data coming at a high data volume. That means continuous data coming on a real-time basis by integrating this cyber and physical worlds actually. So what does that mean is, now in the post-Industry 4.0 scenario, the same equipments like pump in the field or CNC machines in the factory are now equipped with sensors, the connectivity like we have 3G and 4G and 5G is coming soon, and the IoT platform, the software platform. With these three things, we are able to now understand and get the data from these pumps and machines back to the digital world and understand how these different parameters, like for example, vibration, flow, or pressure, are performing on these equipments. In the pre-Industry 4.0 scenario, since there was no way to connect and get the data, we were deprived of understanding how these equipments were behaving under different climatic conditions. But with thanks to IoT and Industry 4.0, we are now able to connect with sensors and get the data over a connectivity to the IoT platform, understand what exactly is happening, and then take a corrective action to ensure that these equipments are up and running and providing the maximum time their services. And there is more to it, right? By reusing the same 3D CAD models that we used in our product development, we take that data back to the physical world in a concept called augmented reality by creating a digital twin. Now, let me demonstrate you with a quick example of an augmented reality. Here, this service technician is going to the field. It's a Caterpillar genset, and he's scanning it with his handheld device, and he's able to understand all the parameters from that particular genset. For example, there is some kind of an alert coming out, and there is a fuel blockage, and he wants to replace that particular fuel filter. Now, the augmented reality animated AR experiences will help him to really understand that and replace the filter in a very quick time. And if he needs to do the services, because his hands needs to be free, and you can also see he's wearing the smart glasses like a Microsoft HoloLens to do the service repair. So with this, the IoT, where we are able to get the data from the field back to the digital world, and with augmented reality, taking the data back from digital world to the physical world to do the service and maintenance of those equipments, we are now able to bridge that gap which was disconnecting these two words, and that basically, Industry 4.0 unlocks that value that was hidden in these data coming from physical to digital and taking digital to physical. So basically, this unlocks the the value with this physical digital convergence, which can be leveraged to improve the product development, the quality of the product, they reduce the cost of the product, and overall transform the business. And we will see more about it as we go, right? So what is the value that Industry 4.0 really drives? Let's see some of these values. The first and the foremost important thing is, as you just saw in my previous slide, where those pumps and gensets are connected, and with those connectivity, now we are able to maintain the uptime of those equipments, and the efficiency of that equipment improves anywhere between 10 to 30%, right? And because of the augmented reality, now service technicians, even if they have to do the service and maintenance, he's able to very quickly do that service and maintenance, and improve the first time fix rates and reduce the overall service cost. So what does that really mean by improving the asset efficiency or reducing operating cost is improvement in the OEE, which is defined as overall equipment effectiveness, which is a combination of performance, quality, and availability. The combination of these two really drives your OEE, which is also the measure of manufacturing efficiency, right? And let's take an example of the, one example, like Bharat Forge is an automotive tier 1 supplier, the well-known forging company. They operate globally, and they, started this Industry 4.0 journey with a vision set by their CMD on zero unplanned downtime, especially in the hydraulics, pneumatics, and electronics. Of course, there was a little bit of downtime allowed in the mechanical side because of the wear and tear of the machines. So when Bharat Forge began their Industry 4.0 journey, they evaluated a lot of industrial IoT platform, and they selected PTC, and they implemented this Industry 4.0 with our industrial IoT solutions in their forging and machining plants. They connected all their presses, when something goes wrong with those equipments, and they took the predictive maintenance kind of approach. Now the result, they improved their overall OE by 15%. Now what does that 15% OE means? With the same in the same time, with the same labor, now they are able to extract 15% more from those equipments. That means they can produce more parts. The machine is available more time, and the quality of the product is still maintained. So that means they can take more orders, so their manufacturing throughput increases, and because of the augmented reality, their service cost and the labor cost also reduces. And as we improve our OEE and more manufacturing with a lesser service cost, ultimately, the Industry 4.0 provides us an opportunity to improve our revenue, and most importantly, the profitability. Let me give you another example of Bharat Forge, how this ROI was really calculated or visualized. In the night shift at 2 a.m., operator observed the abnormality, the vibration of the press, and he found something wrong with that, and he immediately shut down the machine, and he found that one bolt was broken. And this machine was not connected with IoT, with sensors, and if he was not able to that particular on the dashboard by sitting in the control room, he would have probably continued to work on that press, and within a half an hour to 1 hour time, the press would have been the bolt would have been broken, and the press, there would have been a safety issues, and the press would have been down for at least 2 shifts to repair it back. And mind you, the cycle time of that particular press is 12 seconds, and it is one of the important press in an overall forging line, and the cycle time of the overall line itself is less than a minute, which is 45 seconds. If this machine would have been down for 16 hours, then you would imagine very well, the loss of production, the loss of time, and the loss of productivity, and also ultimately the profitability. So that is just one of the several examples, where industrial IoT has realized the value, and Bharat Forge, that's why they are successfully able to implement and improve their overall equipment effectiveness by 15%. So Bharat Forge is just not one example. There are various examples in India and globally, like Tata Refractories, Automotive Excels, Blue Star, Carlsberg, Vestas. There are various local and global companies that PTC so far has connected around 1,500 plus factories in India and globally as well. Okay, so how do we really do this, right? We do this with, before we come to that, let's talk about which are those most high impact, most widely used use cases. The first one is asset monitoring. That's what the first thing is. Like I gave you the example of the press. You collect all your equipments in the factory and start monitoring them, based on their critical technical parameters. The second one is condition-based monitoring. That means while you monitor those assets or those equipments, put certain conditions or certain thresholds. Like for example, if vibration, if it is more than this particular value, or if the temperature is more than this particular value, so that you also understand, not only just you visualize, but you also understand what is happening within those assets. And once we connect these assets and start monitoring with certain business conditions, the next one is really the real-time production performance monitoring, because that's an ultimate aim to really visualize how the performance of the entire plant in terms of our KPIs, like how many parts we produced, how many of them were accepted, what is the overall efficiency in particular shift or day or a week or a monthly, things like that. All the production KPIs can be visualized. I think these three are the immediate or the short-term use cases which can be implemented in as good as few weeks, and a quick value can be realized. And as we progress in our Industry 4.0 journey, the remaining use cases like predictive analytics, like predicting the failure of the equipment before it happens, right? So predictive analytics, or improving the workforce productivity with an example of an augmented reality that I showed just a few minutes back, can be the futuristic or a long-term use cases. Now let us see, how do we really enable these use cases? That we enable it with our PC ThingWorx, that is Industrial IoT Platform. Now to very quickly explain what ThingWorx IoT Platform does, it basically has a lot of features and functions, but I would like to explain it to you in 5 major areas, right? The first one is connect. Like every factory has a mixture of new and old machines. Some of them are connected, some of them are not. But our industrial IoT platform ThingWorx is able to connect to all the machines, irrespective of what kind of PLCs you have, whether from Rockwell or maybe Siemens or Mitsubishi or any other thing. So we can connect to literally any machine, and even the old machine can be made smart and to be connected with an IoT platform. The second one, as we connect and get the data, we provide a role-based dashboard. For example, the operator who was monitoring that particular press in the night shift, had his own dashboard for that particular press. So understanding various parameters of the press, how they are performing. Similarly, a line in charge might want to observe all the parameters of all the machines in that particular line. And similarly, a plant in charge would like to visualize the entire plant, the operations. So once we connect and get the data, we build those kind of a role-based dashboard for an operator or a maintenance guy or a plant in charge, or even to the management to see all, production KPIs across all their plants. And the next step is to really, understand data and make sense of the data. That is called as analytics. So where there are various ways of analytics, that, starting from a basic descriptive analytics with certain threshold or business condition, all the way up to the predictive analytics using the machine learning and artificial intelligence driven algorithms pre-built into this platform to really predict the failure of the machine. The fourth one is basically orchestrating. That is, as we connect, observe and analyze that particular data, sometimes we have to, integrate with other business systems like ERP systems or a CRM systems or an MES systems, or sometimes we need to update the software patch in the PLC of that particular equipment. So instead of taking the machine shutdown and things like that, the industrial IoT platform can automatically send data, or write this data back into those business systems or to the PLC, as with the machine online itself. That is basically orchestrating or integrating with third-party systems. And lastly, for some reason, we need to take some kind of a service and maintenance of those equipments. Then, as we saw previously, using augmented reality with handheld device, tablets, or even the hands-free like a Microsoft HoloLens or a Google Glasses, to really very quickly understand and repair or maintain that particular equipment. So these are the 5 major areas of industrial IoT platform, which basically enables the Industry 4.0. Now, very quickly, let us see all those 5 different use cases that I just spoke about a few minutes back. The first one is asset monitoring. This is a kind of a dashboard, the pre-built dashboard that once you implement Industry 4.0, you don't have to really build this. These are provided by PTC. For example, you see various assets here. There is a CNC milling machine, grinding machine. You can see the specification of those machines, and whether, the most importantly, whether this machine is on, it's not on, or is there any alerts or any warnings and things like that. that. So that is as simple as that. Connect those simple equipment and start monitoring on these kind of dashboards, which can be visualized with large screens kept on the in the factory, or it can be visualized on your computers, or even it can be visualized on your mobile phones as well. The next use case is basically condition-based monitoring, where as you monitor those assets, put certain condition. For example, in this pump, right? As we, with sensors, we are monitoring this, but we have also put certain thresholds. For example, there is a little bit of spike here. So you can see that and the spike is in the red. So automatically an operator or a maintenance guy or a shift in charge or a plant manager will understand that there is something wrong with this particular pump. So that you can go and do the analysis and then take a corrective action before something major happens and breaks, and this pump breaks down. So that is like condition-based monitoring. Okay, and of course there is one more screenshot here which you can tell you, once you understand if there is a spike, then you can go inside and little bit do some kind of a trend analysis and understand how it is, why and how those spikes are coming up. Okay, the third and the most important use case is a real-time production performance monitoring. So this is a pre-built dashboard that PDC provides to really monitor the production KPIs. For example, you see that there are various lines. You see the availability and quality and the performance of each of those lines and overall OEE. All those KPIs are given on a dashboard, which will help us to understand really how our manufacturing operations are happening. If you go one step detail, then these are some of the other dashboards, the sample dashboards that I would like to provide you to get some insight on how you can really monitor this real-time production KPIs. For example, this is at the plant level. What is the overall OEE, and you can also understand. Do some kind of analysis on how these different parameters are behaving over a period of time. What is the top utilization report, or for some reason, if the machine breaks down, then what are those reasons, how much time you have spent in, repairing that, and things like that. So basically you can understand all the details. And from a plant level, you can also go to this line level. For example, I have one more screenshot at the line level. Now, once you go inside particular line inside the plant, then you can also understand that line specific parameters like, availability, quality and performance, the OEE, overall operation of that particular line, and the various, analytics of different parameters as well. Of course, there are various other ways, other information also can be provided in terms of downtime, rework reasons, schedule, the maintenance schedule. So there are various, dashboards can be created. The idea is to provide a complete view of the manufacturing operations and take a corrective actions based on the information provided by these dashboards. Okay, so these three use cases are, short term, very quickly implemented, and with a quick ROI. Now, going forward, the last two use cases I will also talk about. There's a predictive analytics. For example, this is the pump that is used in the oil and gas industry to circulate water. This pump is fitted with various sensors as well as the small computer to collect all the data. Now, if something goes wrong into this particular pump, how does the IoT platform really predicts the failure? For example, here we are simulating the failure, and this particular valve is closed now. So the moment the valve is closed, you see that the flow rate goes down, and there is an anomaly detected at the flow rate, the red marks here, and the efficiency of the pump goes down. And as the time passes, automatically, this pump, the analytics engine inbuilt into the industrial IoT platform understand this data, and it can see that if it continues, the situation continues, then the impeller is at risk, and it may even fail in the next 3 days. Okay, and then a service technician goes there to do to look at the pump, and with augmented reality, you can see that the various sensor data also can be visualized on the top of it, along with the flow rate has gone down because the valve is closed, as well as also you see that there is also a little bit of misalignment in the way the pump is, the foundation where it is installed. So that is how the machine learning algorithms inbuilt into the IoT platform can actually understand based on the data and predict the failure of the equipment before it happens, reducing the costly downtimes, the costly errors, and the overall production loss. Lastly, we'll also talk about the workforce productivity. Like for some reason, you have to go and maintain it. In this example, some valve needs to be replaced. And again, as you scan that particular line, we get the part number of the valve and the various other parameters. If we have to replace this particular valve, then there are certain instructions are animated, provided as an animated experience here to the service technician. For example, he needs to open this valve, open the gate valve, and remove the nuts and bolts and take out this particular valve. And similarly, the valve needs to be fitted back. The bolts and nuts have to be tightened here again. Close this gate valve and close this particular valve. And once we do all of these activities, actually verify that and complete this. So very quickly, the augmented reality can help us to really, do this maintenance without referring to the old manuals or, hard copies and things like that. But we do understand that when technicians go to the field, in spite of those AR animated experiences created or provided, he will still need some kind of an expert help, right? And that is what, for example, we can see it here. This is a remote assistance provided as part of the augmented reality. And, here the service technician in the field, but because of the complexity on the site, he might need some kind of assistance from an expert who might be at home or might be at office. In this example, the expert is basically providing some kind of graphics and annotations to the lady who is on the field, which buttons to be pressed or in which direction this things to be rotated and things like that. So it is more than a video call, or you also do certain kind of graphics and animations or the annotations here, which will really help and guide the service technician who is on the field on what exactly needs to be done there exactly. So this really helps us to do the things right first time right on the site and avoid those costly errors or any mistakes that may happen without the support from the remote people. And especially in the COVID times, you can imagine how how efficient and how effective this will be in helping for the remote collaboration. So going forward, I just want to align this to the Industry 4.0 journey, and this particular the development path or the stages of Industry 4.0 are provided by an institution called Akatech in Germany, which is basically this is a non-governmental organization that provides the industry trends and the new technologies to the government of Germany to frame their economic the policies, and they provided us 4 maturity stages or the maturity index for the Industry 4.0, starting from visibility, transparency to predictability to the final stage of achieving the autonomous or the completely automated line here. Of course, connectivity is as a prerequisite to do this thing. And based on our use cases that what I provided you in the previous slides, for example, asset monitoring, the first thing is to really understand the visibility. Okay, for that we need to so that is what is happening, the visibility. That is by monitoring those different assets. We connect those assets and we start getting the visibility of this. Second step is once you connect and start getting the visibility, then we also want to know why it is happening, right? Yes, there is some problem, but why there is a problem. So for that, as I said, condition-based monitoring, put certain threshold or put certain conditions while monitoring, and you will be able to understand how why it is happening. And I gave you the example of the bolt, the descriptive kind of analytics, how it can really help us to really predict the failure. And the third, of course, the real-time production. As we do this, we will monitor all the key production KPIs. And the last important, use case is the predictive. Like, once we start collecting the data and start understanding, predictive is more futuristic, right? So the machine needs to have a lot of data to really understand what is happening, and then on its own, it starts predicting the failure of the equipment using machine learning algorithms and artificial intelligence. And I showed you the example of the pump when the valve was closed, how it predicted the failure of the impeller in 3 days, right? And of course, the workforce productivity, for service and maintenance using augmented reality can be, implemented at any point of time. So these use cases, what I have also provided, aligns to these, 4 stages of Industry 4.0, like getting visibility by monitoring, getting transparency by understanding what is happening, and then implementing the predictive analytics to really predict the failure of the equipment. As you all begin your journey, just word of caution based on our experience. I've always seen that most of the IoT or Industry 4.0 projects, precisely 75% of them, fail to either take off or just remain in the pilot state. That is because most of the organization focus on the technology, but they don't really focus on the business case and the business value, right? I gave you an example of a Bharat Fort where they started with the vision of zero time, unplanned downtime, right? So it's very important to, align your vision to some business value, like what is really you want to achieve, like 15% OEE or, reduction in labor cost, reduction in, the energy usage and things like that. So, and then you start, evaluating the technology and start aligning them to the business cases. And the second thing is, look for a long-term solution. Though, as I said, you can start with simple asset monitoring or a condition-based monitoring, but look at that, whatever solution that you implement, it has to scale it up, for the future, like, predictive analytics or, prescriptive analytics, or maybe even to have a complete automated. So today you may not implement, but tomorrow, maybe a year or 2 years down the line, the same solution should be able to scale it up. As we say, think big. So we'll have to think big, taking all things into consideration, but start small, maybe with 2 machines or 1 line or 1 plant. Start connecting, get understanding of that, and start realizing the value very quickly, and then act fast. Okay, so you achieve a quick win, a double-digit impact, and once you achieve that small wins, then repeat same thing across all the lines, across all the plants, and scale it up, in a very fast way. Yeah. Okay. So with that, this is my last slide, just to talk about who we are. We are PTC. We have a deep industrial domain expertise that aligns to Industry 4.0. Our leading industrial IoT, like ThingWorks and augmented reality platform, the Euphoria, are industry recognized, very widely used. As I said, we have connected around 1,500 plus factories globally with these technologies. And many of you also might be already knowing PTC, based on our solutions in CAD and PLM with Creo and Winchell, with our 30 years of our engineering heritage. So with our vast ecosystems, with leading technology portfolio, with our partner ecosystem, we really, support our customers and prospects to really capitalize the promise of this Industry 4.0 or the digital transformation. So thank you very much. I'm now open to take any questions, comments, or feedback.
Great. Thank you so much for a great session, Dhirendra. I just want to make one apology and clarification. PTC is actually a US-based company which provides tech solutions in engineering, manufacturing. They do things like CAD, PLM, IoT, and augmented reality. And I'm delighted that Dhirendra Kulkarni is actually here with me live. We're just going to ask him a quick question. Hi, Dhirendra.
Hi, good evening.
Hi, great to have you here. So, Dhirendra, I want to ask you, we can see why Industry 4.0 is being talked about, and we see it all over social media. I mean, you can't pick up something without seeing it. But why is Industry 4.0 not being adopted widely enough in India?
Yeah, that's really a good question. And it is not really implemented or taken off to the extent that what it is expected to do, because we have been talking about this from a couple of years now. Yes, initial few years were more about understanding and getting ourselves educated, but it is time to really unlock the value of Industry 4.0 and implement it. I guess every organizations here in India as well have some or the other form of the digital transformation initiative, and Industry 4.0 is one of the digital transformation initiative. So definitely every organization has it, but probably in my experience, what I see is many organizations, treat Industry 4.0 or more as a technological solution or a technology rather than a business strategy actually. So I think the first thing is, we need to, every organization should think about what is that they want to achieve from Industry 4.0. For example, in the presentation, I spoke about the vision that Bharat Forge had on zero unplanned downtime in electronics, mechatronics,
Yes.
and hydraulics kind of a lines. And it all started with that, right? And then it is broken down into different key business KPIs, and from then you start, okay, in order to do this, then what are the technologies available to enable this kind of a business objectives. I think the key point that many of the organizations are missing is to really define the business objectives and the KPIs that they want to achieve out of this industry 4.0. So if you focus on a technology, you are going to go wrong. You have to focus on a business objectives and then look for the technology. And and of course technology is there. You must have seen in my presentation. It's all there to enable it. But idea is to basically what to enable. I think those definition, understanding, taking it as a strategic level is a missing. So instead of a technology, it should be a business focused initiative. That is something which I feel is missing.
And you're echoing everything we've heard earlier today from Meher Padamji to everyone else. Absolutely, it's got to be focused on what is the business problem and how can we solve it without technology, and then think about the technology solution. So brilliant. Thank you very much for being part of Integr8, Dhirendra. Please accept our virtual certificate, which will be emailed to you. And know that in your honor, we will be planting a tree as a thank you to you to do our bit for the environment. So thank you very much. And everyone else, don't forget there's poll questions, and don't forget you can also ask questions through the chat box too, or through the question box. Join us again after the adverts in a few minutes for the next session, which is all about digitization and supply chains with Amol Nagar from GE Aviation. See you then.
Yeah, thank you everyone. Bye-bye.